My dear friends, welcome to Rajshekhar classes on Applied Data Science with Python. This is lecture number 545. In this lecture, we will try to understand backpropagation algorithm. Before understanding this lecture, I request all of you to go through my previous lecture, that is lecture number 544. We understood memoization and chain rule. Let's understand one of the most important algorithm in the whole of the deep learning is called backpropagation algorithm. Imagine we are given a data set, capital D is equal to xi comma yi. Let me say my data set is capital D equal to xi comma yi. What you do here is you would send each of your point xi, what is this xi? xi1, xi2, xi3, xi4 as an input, isn't it? This is four-dimensional input. Xi has got feature xi1, xi2, xi3, xi4 is input, just like in every optimization problem, isn't it? Now what you have to do, initialize w power k ij's, means weights. Initialize all the weights. And how to initialize, we will learn a little later in this chapter to understand how to initialize. You take each of these inputs for each xi, in D, send xi through this network, isn't it? Just see, for each xi in D, D is coming from data set, pass xi, just see, for each xi in D, send xi, this is my xi, send xi through this particular network, through this particular network, isn't it? Yes. Through this network, your input xi here, xi is basically has four dimensions. What are the xi1, xi2, xi3, xi4? That is four-dimensional data point. Your input xi. I am sending this input xi through this particular network. Pass xi forward through the network. You are sending xi in this direction, isn't it? In forward direction. Just see this one. You are sending xi through this network, pass xi forward through the network. So this step is called forward propagation. What is this step? This step is known as forward propagation because we are propagating this data xi in forward direction, isn't it? Here xi is input and yi is used in loss function. Just see, you have in your data set, you have xi comma yi. What is this xi? I am sending this xi as an input to this particular network. And where is yi? Yi we are using in loss function, isn't it? Yes, here xi is input and yi is used in loss function L of yi cap comma yi r, isn't it? Using this loss function, using this loss, what you get? Just see, what is my loss function? L of yi comma yi cap. Yi from where I am getting? From data set D. As I told you, I am repeating, as I told you, we are sending this xi as input to this particular network, isn't it? Yes, this is initialization of weights for each xi in D, pass xi forward through the network. My C step is what you have to do. What you have to do in B step? To be compute loss, isn't it? Compute loss on yi cap comma yi. Here yi cap here is what is predicted by the network, isn't it? This yi cap is, this one is predicted by network, your neural network. Yes, isn't it? Y cap here is what is predicted by this network, whereas your input is xi. You know what is this xi? We are in data set, you have xi, isn't it? Now, that is step number B. What is step number C? You can compute all the derivatives You can compute all the derivatives using the chain rule and memoization as we discussed in previous lecture. And if you have all of the derivatives, yes, how can I calculate all of the derivatives? I discussed in my previous lecture. This slide I collected from my previous lecture. We know how to calculate all of these derivatives, isn't it? You have all of the derivatives. The next step is, if you have all these derivatives, the next step is update weights, isn't it? Now what I have? I have these derivatives. Once if I have derivatives, certainly what can I do? I can update the weights. That is step number D. 2D, that is to update weights from the end of the network to the start, isn't it? That's important. Just see this one. You are updating the weights in this direction, isn't it? From end to start. That's what it says. You are updating the weights from the end of the network to the start. So you send the input. Just see. From the end of the network to, so you send the input, the input passes through the network in forward direction. You get your loss function, isn't it? You have done your forward propagation. Now we will do backward propagation. The second part of it is, so once if we have loss, I can start computing these derivatives, dou L by dou O31, like that, isn't it? I can start computing these derivatives. Once if I have loss function, I can calculate this. Once if I calculate, I can calculate all other derivatives, isn't it? So once if we have loss function, I can start computing all these derivatives, which means I can start updating these weights. Calculating derivatives means what? I can start updating all these weights. You can always update these weights. For example, let me consider W311, isn't it? For example, I can update weight W311. The older one is random initialization. That's important, isn't it? W311 equal to W311 new equal to W311 old minus eta into dou L by dou W. This anyway the older one is random initialization. Here what is eta? Eta is learning rate. We know that this derivative is nothing but, what is this dou L, this particular derivative? Just how can I calculate this derivative? This derivative dou L by dou W311 is equal to dou L by dou O31 by dou W311. This I already discussed in my previous lectures. We can compute both these derivatives. I can compute these two derivatives. This first derivative, I can also compute this second derivative. Both of we can compute both the derivatives. Once if I have these two derivatives, this is simple update function, isn't it? Once I know these two derivatives, this update function is simple update function for W311. This is simple stochastic gradient descent update with some valid learning rate, isn't it? I update W311, then I update W321. After updating, first I will update W311, then I will update W321. So in backward propagation, what am I doing? When I went forward, I went from input to towards output. Forward means when I went forward, I went from input to towards output. That's called forward prop. When I am coming back, what am I doing? Once I got loss value with the given input xi comma y, I compute backward here. That's why it is called back propagation. We will update the weights in backward direction. So what is happening here? First my third layer, Yes, first my third layer will get update. This one, yes, which one is third layer? First my third layer weights get updated. What are my third layer weights? Third layer weights is W311, W312, isn't it? First my third layer weights gets updated, then my second layer weights get updated, then my first layer weights. In this whole process, we are using chain rule, and we are using what we are using in this whole process. We are using chain rule and memoization. That's what it says. Just see what we are using here. We are using chain rule and memoization. The step D, what is my step D, is called back propagation step. This step D is called as back propagation step. So literally what we are doing here, if you think logically, in the forward probe, we are sending the input and trying to compute the output, that is yi cap. In the backward probe, we are using the error or loss here to update our weights, so that the next that next time I send these inputs, these weights will be better tuned to lesser loss or lesser error. And third step is what is this? What is W311? This I already discussed. What is my third step? My third step is repeat step 2. What is this? What you have to do here? What you have to do? You have to repeat step 2 till convergence. We know that what is convergence. So what is the concept of convergence? Just try to recall. We already discussed it. Just Wkij new must be approximately equal to Wkij old. Then I can say it is converged. If my at any step, if my new weights are very similar to old weights, then I converge to true solution. I request all of you to go through this particular lecture. If you have any doubt, please keep a comment. I will continue my discussion on backpropagation algorithm in my next lecture also, that is in lecture number 546. Thank you very much.